And let's review. Okay, so real super simple one, debated even whether I should put this on there. If we're simplifying a rational expression with monomials in the numerator and denominator, couldn't be easier, right? You're just going to use properties of exponents and reduce the fraction. So in this case, we've got the number part. Because those are coefficients, they're being multiplied by everything on top and bottom, we can reduce that fraction. What's that reduced to? 3. Good. So we get 3 on top. I don't need a 1 on the bottom because if there's nothing on the bottom, then this isn't even a fraction, right? And if there is, then I don't need to multiply it by 1. And then how about the exponents? Yeah, I get z to the 5th. Where? In the bottom. There we go. Good. So 3 over z to the 5th. No big deal. Okay, this is a little bit trickier, right? When we're dealing with division, let's just make sure we're aware of the process here. I picked a division one rather than doing, we don't really need, if we can do this, we can do multiplication because it's part of the process. What do we do when we're dividing rational expressions? What do we have to do first? Factor what? And the numerators. Yeah, we're going to want to go ahead and factor numerators here too. So then what's this give us? We're going to get for our first fraction, what does the top factor into? Bottom. Divided by second, top factors into bottom. There you go, x plus 9 times x plus 7. Okay, so what do we need to do at this stage? Now we don't flip yet. We got to do something first.
Write down the numbers that can't be.
Ah, good. Okay, we've got to list excluded factors because we have to do that for every step that has a denominator in it, right? And the denominators are going to change when we flip and multiply. So here we get x cannot equal what? 7 or, okay, so I'll just say plus or minus 7 or negative 9. Okay, good. So what's next? Flip and multiply. When we multiply fractions, the best way to do it is just make one big division bar and just multiply straight across, right? Okay, so what's in the top already? Pre-flip, what's in the top? Right, now that's the part that stays in the top. Okay, now post-flip, what ends up on top? Okay, what's on the bottom post-flip? Okay, so do we need to add anything to our list of exclusions then? Oh, okay, good. So we can add plus or minus 1 post-flip, right? Now we got all our exclusions, 5 of them, a lot of them. And then finally, what do we get to do? Cancel. Okay, so what can we cancel? Looks like x plus 7s, x plus 1s. So our final answer then, what's left on top? X, okay. What's on the bottom? There it is. Okay, good enough? Give me 1 to 5. Does that all make sense? Okay. Okay, so now let's look at the difference here. So we've got on the left, we've got, is it an equation or not? How do you know it's not an equation? Pretty obvious. No equal sign, right? So if there's no equal sign, we're not solving anything here. We're just simplifying this, right? We're going to add and subtract some rational expressions. On the right side, that is an equation, isn't it? There's clearly an equal sign right there. So that's a totally different strategy, right? And it's important that you pause for a second and think about what you're going to do before you just start doing stuff. Because half the time, if you just start doing stuff, you're going to do the wrong thing and waste time and confuse yourself. So if I'm trying to add or subtract rational expressions, I'm just essentially adding and subtracting fractions that just happen to have variables in them, right? Well, adding and subtracting fractions requires that we have a common denominator. Okay, so what do we do first then? Well, we got to factor all the denominators. Do we factor numerators? No, we don't factor numerators. When you're adding or subtracting fractions, not only is it not necessary, it's a bad idea, right? There's no need to do it because ultimately, think what we're going to end up doing several steps down the line. We're going to get common denominators in all of these fractions. And once we have common denominators and we're adding and subtracting terms, we know how to do that. We just push everything together into one big fraction with a common denominator, where we're going to combine everything on top then. Well, it makes it a lot easier to combine stuff if it's not factored. If we factored it, we'd have to turn right around and undo all that to expand it all out and combine like terms, right? So don't factor the tops, only the bottoms. We're going to get a common denominator in each term, push them all together, and then simplify. Okay, now that's different than what we do when we're solving rational equations. Here, our goal is to clear fractions so we can get a simpler equation to solve, right? Well, how do we clear fractions? We're going to factor all the denominators, again, not the numerators. We're going to distribute the LCD, just like we do with numerical equations where we don't have all these rational expressions with variables, but we've done this from the start of the year when we have fractions with numerical denominators, right? We multiplied through by some number to clear fractions. That number is just the LCD, right? Distribute the LCD through, it's going to cancel stuff, cancel all the factors in each term, and then we just write the equation in standard form, meaning it's set equal to 0, and solve. Whatever equation we have, we just solve it. But it's a much easier equation at that point because it's not a rational equation. There's no variables and denominators anymore, right? So we got to make sure we're identifying what our strategy is and following that. So what are we doing here? Are we solving or simplifying? Simplifying, yeah, we're just simplifying. Okay, so if we're going to simplify, we've got to, first step would be what? Factor denominators. Good. Okay, so if we factor denominators, then what's that going to give us? The first term needs to be factored. The other ones are already done, right? So what does the bottom factor into in the first fraction? X plus 3, x plus 1, and on the top we've just got our 2x squared minus 3x minus 7. The rest of it's fine. It's already factored. Okay, so now what? Yeah, we got to get common denominators, don't we? Okay, so how am I going to accomplish that? How am I going to get, what is my common denominator going to be? There's the first question, I guess. Yeah, x plus 1 times x plus 3, right? There is my LCD right there. So what would I need to multiply my second fraction by to get an LCD? Okay, just the bottom? Top and bottom, okay. How about the third fraction? Divided by x plus 1, and I would need that in parentheses then, wouldn't I? Okay. There we go. So now look what we've got. Now we've got our common denominator there, there, and there. So next step. Well, we're going to push everything together, write it with one common denominator. So now this is all going to look like one big fraction with my common denominator, x plus 1 times x plus 3. Now, what's going to be on top? Well, I've got this whole thing minus, right, minus this whole denominator plus that denominator. Okay? Give me 1 to 5 so far. Are we good? Okay, good. And then now we just have to simplify the numerator, combine like terms. So what's that going to give us on the top? So we're going to get 2x squared minus 3x minus 7 minus x squared minus 3x plus 6x plus 6, right? All divided by x plus 1 times x plus 3. Combine like terms. How many x squareds are we going to get? 1, okay. How many x's? 0. Okay, so the x's go away. And then I think I messed that up. I'm down wrong up there. Oh, I guess I didn't. No, we're good. Okay, never mind. And I get minus 7 plus 6 is minus 1 over x plus 1 times x plus 3. Okay, so we done? Now we factor the numerator. After we've simplified the numerator, we've got to see if we can factor it.
Could you scroll up a little bit, please?
Yeah, I will. Right. But see how we got that? We push these together, we just get first numerator minus second numerator plus third numerator over my common denominator. Okay. Now, do I need to exclude anything here? X plus, say it again. So what values do I need to exclude then? Okay, so x cannot equal -1 or -3. Now I got to exclude values before I cancel, right? Before I cancel factors. Are there any that cancel? Yeah, those guys go away, right? So this does end up looking a lot simpler. It looks like x minus 1 over x plus 3 with those exclusions. Oh, hang on. Yeah, with those exclusions. Yep. Good? Make sense? Okay. All right, now this is different, right? This is one where we're just going to try to clear fractions. Okay? So, because we're doing an equation, right? So we solve rational equations by distributing the LCD to eliminate fractions, right? Clear fractions. So what's that going to give me then? I've already got a factored, and unfactored. The middle fraction, the second one is unfactored. So I've got to factor that denominator, correct? So we get, if we do that, 2y over y minus 3 minus 2y minus 3 divided by what factors? Okay. Equals negative 4 over y minus 5. Okay, good. Now what? Okay, what is my common denominator? Y minus 5 times y minus 3. All right, so that's what we're going to distribute through the entire equation. Okay, now I don't think you can shorten this up a little bit. You don't have to write out what you get when you distribute that to each term. You can just sort of cancel as you go. Here's what I mean by that. When we distribute to our first fraction, what's going to cancel? The y minus 3s are going to cancel. So what do I end up distributing then to the top? Y minus 5 only, right? So that first distribution is going to give me 2y times y minus 5 minus the second distribution. What's going to cancel? Okay, so everything cancels, right? From the red LCD. So what am I distributing? Just a 1, right? I'm not distributing anything. I just leave that one the way it is. So am I writing this correctly then? Well, oh, okay, I need parentheses, don't I, right? Because I'm subtracting that entire numerator, so I need to group it as a quantity. Equals, how about on the other side? When I distribute over to here, what cancels? Okay, so then the only thing I'm distributing is, okay, so I've already got a negative 4 there. I'm going to distribute to that y minus 3, and voila, look what we've got here. We only have an equation involving variables in the numerator, right? There aren't any variables in denominators anymore, so that's good. Now all I've got to do here is just simplify this, put it into standard form. So if I distribute the 2y, I get 2y squared minus 10y. If I distribute the negative here, everybody agree I get minus 2y plus 3. And on the other side, I get minus 4y plus 12. Okay, so then let's push everything over to the left side where I've got positive coefficient of y squared. So 2y squared, how many y's do I end up with on the left? Negative 8, there we go, because I've got negative 12 to start with. I'm going to add 4, so I get negative 8. What's my constant going to be? Negative 9 equals 0. Okay, so could I factor that? What would my magic numbers have to multiply to? Negative 18, right? 8 times c. They have to multiply to negative 18 and add to negative 8. And that is not possible, is it? Not possible. So that's not going to factor. So what do we do instead? Quadratic formula, sure. What's that going to give us? If we do quadratic formula, y equals time, or 8 plus or minus 64 minus 4 times 2 times negative 9. What's that? I'm subtracting negative 72, so I add 72, all divided by 4. Okay, so we can, what's that give us then? Inside here, we're going to get 64 and 72 is 136. That's not a perfect square, so we know we're going to get stuck with a square root, right? So we might as well split this fraction. 8 over 4 plus or minus the square root of, this is, all this stuff right here is just 136. So is there a perfect square factor of 136? 8's not a perfect square. No big ones, right? 4 goes in. So that's going to give us the square root of 4 times the square root of 34, right? Because 136 is just 34 times 4, okay? So then why do I want to pick that? What's that give me outside? No. 2 square root of 34, yeah. Our outside number becomes a 2 because that's why we, like when we do couples go out, singles stay in, like when you guys really want to do that quicker, you just want to think about what's the biggest perfect square factor. Because if I can write the radicand as the product of a perfect square and an irreducible number, something that contains no perfect squares, the square root of the perfect square is the part that goes out. The square root of the other irreducible part is the part that stays in, right? So we get 2 radical 34 over 4. And so we get our complex, or not our complex, our conjugate answers are 2 plus or minus square root of 34 over 2. Okay, good? If I did all that algebra or that arithmetic right at the end, I think I did, but it's, hope I didn't mess up. Anyway, make sense? Okay. All right, so then the one last one that I didn't do last period that I got to thinking, I probably should have done one of these. These are super easy, super fast. But if I'm solving a proportion, single fraction equal to single fraction, what do? Cross multiply, absolutely. Okay, so we cross multiply to clear the fractions, and that's going to give me x plus 9 times x plus 1 equals 15 times x plus 1. And if I FOIL that out, I'm getting what? X squared plus x plus 9x. So that's 10x plus 9 equals, okay, if I put that into standard form, minus 6. Okay, so then we're going to get, we can factor that, can't we? So x minus and x plus 1. So we get the solutions, x equals 6, x equals negative 1. Good? Maybe not. We're not done yet. If we check those, what would happen? Negative 1 can't equal x. And we could have seen that right from the start, because from the very beginning, we could have said, aha, x cannot equal negative 1, because we can never have, that had to be an excluded value, right? So an excluded value means that if I get that solution, it's gone. That's excluded, so it can't be a solution. So we only get a single solution, which is x equals 6. Good? Okay, I'm going to postpone the rest until the graphing part. We'll do that on